In the present video, we're going to show you examples of a function, a program that I wrote to draw some polygons, some regular polygons in plot XY, as well as the location of text in the plot XYs, and how to produce implicit plots in such a plugin. And so we're going to start by showing you a particular SMAT Studio file where I have three areas, and the first one is called polygons in XY plot. If you were to define a matrix with two columns showing the coordinates of vertices of a polygon, like in this case is a rectangle actually, if you just type the name of that matrix in in XY plot in SMAT Studio, I'm sorry, it's called M, not M1, so let's get rid of that M1 in there. Then you get the figure of the polygon. In this case, the first line, -1, -1, was repeated at the end in order to close the polygonal. So what I've done here is to create a function that I call polygon to produce a regular polygon inscribed inside a circle. This polygon has NV sides. The circle has a radius RD, and the polygon starts at an angle theta 0. To show you how to do this function, I'm going to repeat it down here, and here's where you need to know how to type the name of the function polygon. Just type polygon, parenthesis, NV, comma, RD, comma, Q, Control G, 0, space bar, column. Now you have to go to the programming palette and insert a line. And as you can see here, we have 6 spots in that line. And so we're going to click slightly to the left of the line. Slightly to the left of the line. Make sure to get that double arrow in there. And then when you get it in that corner, drag down till you have 6 position. I have 3, 6, 7 out there. So I'm going to go back out. And then we're going to start typing the elements in here. So you start with uppercase D, Control G, Q, Control G, column 2 times P, Control G, space bar divided by NV. In the next line, by the way, all the details of what you need to type are presented in this text. I'm just repeating it. So here we go for the second one. I go Q, Control G, D, column, range, parenthesis, Q, Control G, 0, comma, Q, Control G, 0 plus 2 times P, Control G, space bar, comma, Q, Control G, 0 plus D, uppercase D, Control G, Q, Control G. And we completed the second line. The third line is XD, column, RD times cosine, parenthesis, Q, Control G, GD. And then we do a couple of space bars to select the right hand side, and then we go to the matrices palette and select this vectorized function. And something similar we're going to do for YD, column RD times sine of Q, Control G, D, space bar, vectorized function in the matrices palette. For the next line, we have M, column, augment, parenthesis, XD, comma, YD. And I'm sorry, YD. And then finally, the final line is M, column, stack, parenthesis, M, comma. And now we're going to insert a matrix, and so we can go here to the first icon in the matrices and select one row and 2 columns to insert, and then we put XD bracket 1, click on the next space, and we go next space ready, YD bracket 1, and with that we have completed our function right here called polygon. And so what I'm done here is, by the way, this represents the number of sides in the polygon. This represents the radius of a circle where the polygon will be inscribed, and this is the angle where it starts. And so I have a polygon with 5 sides, with a radius of 5, and starting with the angle at 0. If I type here the name of that matrix M11, then I get that particular polygon with 5 sides and a circle of radius 5, and starting at a theta angle of 0 right here. If I put it at pi over 2, I'm going to get this particular polygon. If I put a pi, the same polygon, the same pentagon, you get that result. And then I show you here the 6 sides. I use a radius of 5 for all of them to facilitate copying the graphic. But I change the number of sides here to 6. This one has 7. And then the next one has 8. And this one has a 10. Is a decagon. And this one has 20. And the last one has 100 sides. And when you draw something like this, it is almost indistinguishable from a circle, meaning that in the limit, the polygons will form a circle. The regular polygons will form a circle. Regarding text and color in XY plot, we need to provide a vector where the first element is the position of X and the second element the Y position of the location where this text string is going to be shown. The next is the size of the font in point, and next is the color of the text. A simple case here, I just put the whole information as the entry for my graphic. And here I'm saying, okay, I'm going to put a 3 in X, that's 3 in X, 4 in Y, the upper left corner. This text is a sample text, size 12 in color blue. Now I added a second specification where I'm going to put the word higher, size 20 in green at 5/8. I changed here, kept sample text, but changed the second specification, actually forming a matrix right here. You can see right there. You can have a brace here with 2 vectors of a matrix with 2 rows to put that particular information. In here I put a whole list of 5, a matrix with 5 elements, with 5 rows actually, with the X and Y positions, the text, the colors and the sizes, and I was able to write this verse, I would say. If you don't want to see the colors, not change the size of text, simply do not specify the size and the colors, and it will give you the default blue or black. All right. Regarding what colors to use, there is this listing of the names of the color with the corresponding color that you can try. And I give you an example here of just plotting a single point with a single character in different colors in this particular graph. All right. Sorry. Regarding implicit plots, basically what it is, what you have to do, if you have an equation for which it's very difficult to isolate y, in this case it's not too difficult, but I use it as an example, just make sure to rewrite this equal to 0, and so the expression that results in the left hand side gets placed as the input to an XY plot, like in this case, and then XY plot produces the implicit figure, like this circle. I put a couple of functions here. This is one of a circle, and this is a parabola. Put it in braces, and you get the 2 results. In this case, I actually put 3 of them. And then I use the legend to identify the 3 curves. And so this is what I wanted to show you about the abilities of Plot XY to produce implicit plots, to put text in the graphics, and this example of a function where you can produce regular polygons in the graph. And that was the idea behind this particular video. We ended at this point.